Hey, everybody, and welcome to another episode of Elixir Mix. This week on our panel, we have Josh Adams.
Now with goats.
Mark Ericksen.
Hey there.
I'm Charles Max Wood from devchat.tv. And this week we have a special guest, and that's Ben Schmeckpeper.
Hi, great to be here.
Did I get anywhere in the ballpark?
You nailed it. Most people don't get it right, but you got it right.
Nice. You want to introduce yourself real quick? Let us know who you are, why you're famous, whether or not you have goats.
I don't have goats yet, it's because I have goals. So I am a software engineering manager at a place called Kenna Security in Chicago. So we are like a vuln management company that helps our clients stay safe. We're a Ruby shop. I've been a Ruby developer for 7 years now. Started with Rails and now doing a lot more just pure Ruby stuff. I've been interested in Elixir for a long time, since 2015, and I've been doing a lot of stuff on the side. Probably the thing that's gotten the most visibility for me, at least, I'm not sure that I'm famous, is I was doing some spike work at work to investigate moving some stuff that we do over into Elixir. And as a result of that, I needed a way to parse XML documents. I didn't find an existing Sax parser in Elixir, so I created a library called Slax that wraps an Erlang module that does Sax parsing and gives it a nice Elixir front end that you can integrate with and use in your code.
Is that xmerl?
Yes.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code devchat at Sentry.io to get 2 months free on Sentry's small plan. That's code devchat at Sentry.io. Elixir. I'm going to have to commandeer that word.
So I do think it's worth talking about what is a Sax parser, like SAX.
Yeah, that's a great question, right? So Sax is one of two main methods that I know of, at least, for parsing XML. So there is the DOM, D-O-M, document object model, and then Sax. So Sax stands for streaming.
Simple API for XML.
That's right. Simple API for, thank you. Simple API for XML.
I have this document open right in front of me.
Yeah. So Sax parsing is it's more of a stream-oriented approach to parsing XML, whereas the DOM model is more of the document model, where you would parse everything at once and then be able to make arbitrary queries using stuff like XPath. So that feels a lot more natural, especially people who have, done things with jQuery. We can say, give me all divs on a page of HTML. It's a lot similar. The DOM model, you can say, give me all authored nodes, and then take the names out of those nodes. Whereas with simple API for XML, Sax parsing, it's really just more event-based. And so every time some element in the document is encountered, a callback in your code gets called, and you respond to it. But there is no greater, if you want to maintain state, you can maintain state, but there is no greater state maintained by the parser. So it's a little bit more work up front for the developer, but there's trade-offs to be made, obviously, and Sax allows you to parse larger documents because you just don't have that memory requirement of the document of DOM parsing.
So I'm curious, you mentioned your Ruby shop. Is that how Nokogiri works?
Yeah, so Nokogiri is predominantly a DOM parser. I think there is a way to do Sax parsing from Nokogiri, but the times I've used Nokogiri in the past, it's been DOM parsing, where you handed a string representation of XML, it gives you back an object, and then you can make XPath queries. You say, here's my query that defines all the nodes that I want, and I get back a collection of them, and I work with that collection.
Interesting. Okay.
So I'm curious as to what kind of documents, when I had not previously been familiar with Sax parsing, like DOM object model, is the way that I'm most familiar with XML. And I have dealt with a lot of XML documents, and that's, I'm dealing with maybe an external service, like a SOAP service or something like that. And there are XML, like it still exists in the world, and people still write in Java for some reason, but we still have these documents that we have to deal with. So you're talking about like something special is about these kinds of documents, like they're extremely large, right? Like why would I need Sax as an alternative for parsing?
Yeah, I mean, it's mostly around just the memory impact of parsing a very large document, right? So this comes up a lot in my job because we deal with assets and vulnerabilities, right? So basically what we do at work is a company will run a network scan, which then will return basically an inventory of all of the machines that it found on the network and all the vulnerabilities for that machine. And then we ingest that data and do some processing on it. So we're dealing with large amounts of data, and it's not unusual for these XML files to reach over a gigabyte into multiple gigabytes, right? And so all of a sudden, if you're gonna try to DOM parse that and get back a hash or something similar to a hash, now all of a sudden you've got a lot of memory pressure from that, and it's multiple gigabytes of memory overhead. And we're running Ruby, so we already have a decent memory footprint to begin with, and so we start bumping up against the limits of our machines. So Sax parsing lets you deal with it just a chunk at a time, right? So I might have a gigabyte of XML, but really I'm only dealing with a node at a time, and a node's a couple bytes, maybe a kilobyte if it's a very large node, and then I can hold on to the pieces of data I actually care about without having the overhead of the entire document in memory at any given time.
Well put.
And there's other, Sax parsing has a few other benefits in that, right? So DOM parsing requires that you have the entire document available, right? You can't interact with it until you finish parsing. And so, you got to get all the way through. You got to have that final end tag before you get your object back. With Sax parsing, you can really stream the data through because you don't need the entire document. You can just say, given the XML, given the chunk that I'm looking at right now, here are the events, here are the the different pieces of it. And so if you are, say, reading off a network socket, you can just take it in chunks and just stream your way through it without waiting to accumulate everything. And so that also reduces the memory footprint because you don't need to buffer everything, and it lets you start processing a little bit sooner.
And the sender could also be streaming that to your socket.
Exactly.
So I was a little surprised to learn from Josh this before we got on the call that he has been using a Sax parser previously. So he has some real world experience with this. Josh, do you have anything some perspective that you can bring to that?
Generally, it's just I like the model really a lot of doing Sax parsing just because it is just event based. So it's like if you think of the XML document coming through as just like stuff that happened or like an event stream kind of model, it works really well if the document is sort of made that way. I don't know, but in general, yeah, like most of the time it was to manage sort of memory, just keep memory sane, because I was doing this stuff with Nokagiri Sax Parser when I did it in sort of bulk. And yeah, like Ruby, it's very glad to grab lots of memory if you let it. Anyway, so for me, it was mostly about getting around that, but I also did some streaming. I don't remember what the source was, but we had some source that would stream XML documents to us that were events. And so we just got to handle kind of a streaming protocol that was just, we'll send you some XML.
So Ben, I was curious as to, you like right now you're doing a lot of Ruby full-time and you're experimenting with this. So what was it like? Because this is, I would say it's probably not a trivial experiment with Elixir to build a library that's like a kind of like an esoteric XML parser. So what was that like developing that in Elixir?
Yeah, it wasn't quite as bad as it probably sounds. So this was a situation that, to me is one of the great benefits of Elixir is that it's built on top of Erlang, right? And so I didn't have to get down into the guts of like matching up angle brackets and doing all that stuff and understanding all these idiosyncrasies of XML, which is very complicated.
That sounds fun.
Yeah.
That sounds so fun.
It sounds great.
No joke though, writing parsers is really fun.
I'm sure it is. But yeah, you know, some of the tokenization and stuff, and yeah.
Yeah, so Erlang and Elixir are like super well suited for writing a lot of types of parsers without actually like writing a parser. But I would bet that xmerl probably has an actual yek parser.
Mm-hmm.
Yeah, I was going to say, sounds like, you know, and I was going to ask this, but Ben's already answering it. So it sounds like mostly your expertise had to be in adapting an Elixir library to, or an Erlang library to Elixir, rather than being an expert in necessarily parsing XML.
Right. Yeah, I was able to find an existing Erlang library called Erlsom that did Sax Parsing already. So I was able to basically think of what is the interface I would like to use for Sax Parsing, and then create that and just wrap Erlsom with that interface so that I could, you know, make Elixir calls and, you know, deal with structs instead of, you know, a 5 tuple that Erlsom would normally give back, and do those kind of things. So I was able to focus more on the usability and how your code interacts with it, and not have to get down in the guts of handling, you know, XML processing instructions and all these different things that I really don't know how any of those things work in XML.
Ergonomics.
It's a good way to put it.
So how do you decide then what the ergonomics of your API feel like then, right? How did you design that?
Mm-hmm.
Because I always design mine, and then I always have to go back and go, yeah, that sucked.
Yeah. Yeah, it was nice. Right. So I was doing this like as a part of a larger project where I was like the only user of this library early on. And so I was, you know, able to do a little bit of that iterative approach of, you know, try something. And, you know, it turns out my code doesn't look so nice when I have this interface. Let me tweak it a little bit. And I think the big thing that I was striving for was to make pattern matching read really well and be really easy to use. I think that's, you know, that's a great benefit of Elixir, is being able to pattern match in function heads. And when you have this event driven style that is Sax parsing, right? So like I'm getting my callbacks getting called every time I see a start tag, but I can write one function head that matches start tags with start tags of the type author, and a different function head that start tags of the type books, for example, right? And like I can have two very different methods that are delineated by the function heads without having all of this complicated logic that would normally exist in, you know, if you were to do this from Ruby, for example. And so I kind of started there as like, how do I want pattern matching and function heads to play into it? And then in order to facilitate that, what kind of events, what kind of data do I need to be getting out from the parser? And so I took Erlsom wraps, just returns tuples that have, you know, an atom at the start and then whatever variable data after it, which is, it works, but if you want to, you know, match a part of it, now you have to do the whole tuple and put in underscores for the parts you don't care about. And so I was able to grab those tuples and transform them into structs. And to me, pattern matching against a struct reads a little bit cleaner than pattern matching against a tuple.
I agree. And so I'm just looking at your blog post where you have some sample code of what this looks like. And I think people should certainly check that out, especially if they're dealing with large XML files, and this might be an interesting solution for them. But so I was curious, like now you've seen both sides of the same kind of tool. You've seen like the Ruby version, which you've been, you know, you work with on a regular basis, and you have this Elixir version. And are you happy now with? Are you pretty satisfied with the API, like the pattern matching and the way that's working?
I am, yeah. I really like the way pattern matching came out, and really when I'm in Ruby, especially working with Sax Parsers, I wish I had pattern matching, because the code, at least the way I've interacted with Sax Parsers and Ruby, is, you know, you build up a lot of internal state, and then you have a lot of conditions, which is like, if I'm operating on this kind of tag in this situation, you know, these are the two lines I want to run, and then else. So you have these long conditionals, and really the pattern matching, to me, it turned out really well, and it let me write the kind of code I was hoping to be able to write. So I am very happy with the way Slax turned out, and it is one of many reasons why when I'm writing Ruby, I wish I could reach for some of the Elixir niceties that we have.
And if anyone was curious, I checked your first real commit, and there are tests in the first commit.
He is a real coder.
I wanted to see. I figured they'd be there because he was doing it for an actual project, and like that's what I would do in that situation. It's like, here's what I want to write.
Yeah, testing it. I haven't gone. I should go deeper and like have more arcane XML. It's a lot of very simple XML that I'd make sure parses nicely, but the speed with which you can test in Elixir makes it so nice, and especially this kind of stuff where it's very simple. It's I give you a very short XML snippet, and I make sure I get the right stuff back, and the tests run in tenths of a second. It's just a great feedback loop.
Yeah, well, and it's interesting too. I mean, I see teams that don't do testing or don't do much testing, and I'm not going to argue, about how a team works, but this is something that you expected other people to use. So I appreciate seeing tests in it from step one, right? Because then you knew that it was doing what it was supposed to. And then if I need to go use it, I can go look at the tests and maybe add a test case if, there's something missing there that I care about. So.
Yeah, I don't have the best testing discipline, but definitely if I'm writing something that I know I'm going to distribute widely, especially outside of my company to the greater community, I'm going to make sure that there's tests there and that it does what I say it's going to do.
Yep.
So what kind of reception have you gotten inside your company? Are they like, wow, this is a good solution, we want to deploy this or something like this more widely? What's that been like?
Yeah. So we've built out a pipeline in Ruby that ingests basically all the data we deal with. We have different integrations for all of the scanners, and then we canonicalize things, and everything flows through a single pipeline. And that's been working really well. But I did this spike on Elixir because there is, one scanner that we interact with a lot that the API is just very slow. And I've never been able to figure out if it is intentionally slow and it's just that's the way that they rate limit, or if there's stuff behind the scenes that they're doing that slows things down. But, an API call to get what they call detections, vulnerabilities for like 1,000 machines can take minutes. But the API allows you to make 6 simultaneous requests. So they explicitly say in their documentation, yeah, things are slow sometimes, but you can use threading to solve that problem. But we have this pipeline built out in Ruby that is very much single-threaded and very hard to break out of. And so it's been this thing we've been kicking around for a while. It's like, what would this look like if we threaded it, and how would we do it? And because of design choices we've made along the ways, like there's parts of it that are just very hard to multi-thread. And so I said, let's take a look at what it would look like in a different language where threading and concurrency is like more built in and more of a first-class citizen. And so I did this work on getting it into Elixir, and it was well received. It's something we want to get into more. Like the pressure to get this data in faster is growing. It's really our hurdle right now is we have an entire infrastructure built up around running Ruby and deploying Ruby and all these things. And so some of the infrastructure side of running Elixir in production, we're still working through. We're on the path towards having containers, and it's kind of the accepted solution right now is like, let's wait until containers are in production, and then we can drop Elixir in a container, and we don't have to worry about all the complications that come from trying to deploy a release and making sure we have the systems and operations team leveled up on Elixir. Like running in containers is going to alleviate a lot of those problems, and we are very close to having a container solution rolled out.
Awesome. That is one of the huge benefits of containers. Is once you've got them, you can put anything in them, and operationally they're very similar.
Yeah, I can't wait.
And to me, this is the real interesting problem, right? I mean, connecting an Elixir, making an Elixir library that sits on top of an Erlang library, that's interesting. Solving some of these technological issues, interesting. But it's the how do we switch over, right? We have a system that looks so promising, looks like it can make our lives better in these ways, and here are all the reasons with our company and our infrastructure and our people that make it hard for us to, to make the changes that we would have liked to have made in Ruby to make it multi-threaded. And then, okay, well, so we went with an Elixir-based solution, and now we've got the same kinds of problems, except it's moving over the infrastructure. And a lot of times the companies, they look at the technology as kind of the silver bullet. And it's like, hey, look, this will solve all of our problems. And then you get to the other issues where you've got the people that you need to train. You've got the infrastructure that you've got to figure out. And that's really the crux of things. And I'm really curious, what is the major obstacle? I mean, you're talking about, we don't want to necessarily figure this stuff out, so we're waiting for containers. But I mean, where are you getting hung up? Can you not just deploy Elixir on there and run the program, or is it, what are you hung up on there?
Yeah, so I'd say there's a couple things. Like if this was a showstopper, like if the business was being actively harmed by our inability to run multi-threaded, like we would certainly push forward and like figure out a way to shoehorn Elixir into production and get it running. I think it is in some ways at least right now, getting multi-threaded, getting this integration running multi-threaded is somewhat of a nicety. Like it's going to make things easier for us. Clients will be happier that their data gets in sooner, but they are not like, 6 hours, a 6 hour run overnight is not killing anybody, right? Running it in 2 hours overnight is going to be better for us. We get better utilization, all these things, but the business is not actively being harmed. So there is a little, there's not as much urgency to like shoehorn in a less good solution, I would say. And we also have, we are a security company and we care a lot about making sure that the boxes we're running on top of are patched and secure, and that we have, nothing's going to take us down, and that we're, when we're running in production, we're doing all these jobs, we want to make sure that we're stable and our clients can trust that, we're running on solid infrastructure, and there's just is not a lot of Elixir expertise on the system side of the company right now. Like it's something they're interested in, something we're working on getting there with, but systems team. So we have a dedicated team of four systems people who keeps all of our machines up and running. We have, dedicated instances in AWS that they manage and these kind of things. And there's no lack of demands on their time, I would say. Like there's always something, there's something else they need to be doing. There's another request from a client who's paying real money and all these kind of things. And so just getting all that stuff scheduled has been a little bit, basically what it comes down to is, there's already this effort to get containers out, whether or not we switch to Elixir. So that is already moving. It is very close to being done. And so, kind of the calculus of there is business value in switching over to a multi-threaded solution, and Elixir seems to be the best way to do it, but it's not so pressing that we need to leapfrog ahead of all these other concerns that systems are trying to deal with right now.
Right. And I love that. I love just the discussion of, what? A lot of this stuff makes sense for us, but we understand what our priorities are. And it sounds like you've got a good communication structure and things like that with the rest of your organization. And again, a lot of times I think we kind of look past that and not realize how important that is. And so, then you can look at it and have the discussion with everybody and go, okay, so, a lot of these problems are going to be dealt with, soon. And in the meantime, what we have works.
Yeah. I'd say in general, we do a good job of being very pragmatic about the stuff we do. Like we recognize at the end of the day, the company doesn't exist for us to write cool software. The company exists to, deliver value to our clients and make sure that we can monetize that. And so, the fact that we get to write cool software along the way is a bonus. But the answer is not always writing cool software, right? Sometimes the answer is finding a way to make things work that you've already written and, get a little bit, squeeze a few more dollars out of that.
Boy, if that isn't a boiled down of business, I don't know what is.
But I thought the company existed so I could try the new shiny. That was the reason they're there. That the founder, he's like, I just need to create a safe place where people can just play with shiny things.
There are companies out there like that, but
yeah.
There's still got to be that pragmatic end of things.
Yes, it's true.
Mm-hmm. And I've been a manager for a little over a year now, and it's interesting how much my my view on all that stuff has changed. And there's frequent times I'm talking to my team, people slow down, let's remember why we're all here, and like it's nice that we get to do cool stuff, but at the end of the day, business needs to make money so we can all get paid on the 15th and the 31st.
Yeah, but you also need some kind of like pressure release valve for the fact that you clearly are having to deal with Nessus scanner APIs all day. And I've done that, and that's what side projects are for. Sanity.
Yeah.
Yep. I will say we kind of talked about containers there, and the path to containers, and I will say that was something I underestimated in terms of the amount of work required to take an existing mature application. Like in this case, I have some Rails applications and some Elixir ones that they've been being deployed to managed EC2 instances, like just we are managing them ourselves. And now it's like, okay, well, we want to put these in containers so we can put them into Kubernetes so we can have all these other operations benefits. But really, I mean, like it's like just today, just this morning before we got on, I got it so this Rails application could run rescue jobs in a container in a deployment for a Kubernetes deployment. And it's like, because that's not the way Rails is designed to run. Like, it's all about forking off processes and running in background jobs, and containers don't want that. So it's been interesting. Just like, I think it is where we want to go. It is where the industry is going. There are a lot of benefits for going to containerization, but I think we may underestimate the amount of work it takes to get there, like with an existing project. And like I've seen the same with Elixir, where people were just not being aware of what they were doing and the impacts, like loading environment variables at compile time and putting them into module attributes. So they're like, they break stuff. It's like, no, okay, I got to find all these and fix them. So it sounds like you've been dealing with some of that too, Ben. Is that right?
We've been talking through the rescue and sidekick background jobs with containers a lot. Like that is a way, like our pipeline gets kicked off with rescue stuff. And like we just have long-lived rescue jobs, which works really well. But then you consider, like, we're going to a container and how is this going to be different? And like probably ideally what you want to do is, instead of running a rescue job, you just want to spin up a container and let it run for the duration of the job and then get rid of the container. And so we've been talking about what that looks like and the changes we need to make on our end in the application side, the changes that need to happen on the system side, and just all the coordination that needs to go back and forth, and make sure everybody has the same understanding of, at the end of the day, this is the design of the application, this is the infrastructure and the architecture, and this is how we envision it working, and make sure that the application code and the system stuff all lines up, and you're talking to each other using the right verbs and the nouns and everything.
What do you do to make sure you're on the right page with this stuff?
Yeah.
You're on the same page, not the right page, the same page.
That's great. I mean, we are in kind of a sweet spot right now. We are growing, but we're not super large. So we have, I would say, 20 or so developers, and then a team of 4 SREs and 4 systems people.
SREs?
SREs, site reliability engineers.
Okay.
So they we have systems people who are keeping the machines up and running. The SREs, their job is like understand the code and monitor how it's doing day to day in production. And the developers, we're just, we keep cranking out new features. There's natural tension that arises all the time between developers and systems, because I'm a developer. My job is to get new features out as quickly as possible. And the system side, their job is to keep the site up. Right? And the easiest way to keep site up is not change anything. So we go back and forth, and we have a healthy dialogue. All the managers in the company get together every week and talk about what's going on, and that information trickles down. But we're still small enough where everybody on the development side knows everybody on the system side. And if something arises, or you have a question about how the code you're writing is going to perform in production or be rolled out or anything like that, like it's a short walk. It's 20 yards to get down to the systems area and just sit down and talk to somebody. And so that's not something that scales, right? Like it doesn't, when you're 200 developers, it doesn't work that way. But we're still in that sweet spot where we can fall back on that face to face, and then slowly start building out the processes that facilitate that communication once the face to face stuff becomes no longer possible.
Well, and then if the system side becomes too reluctant to ship new code, what you do is you put in little things that you know will break once a week. And then they have to put out the next release.
You sound like you may have experience with this.
This is the part where Josh gets Ben fired. Great.
No, anybody knows better than to take my advice.
Yeah, we're fortunate enough. We still do continuous deployment, right? So we don't need them to like green light deploys
Awesome.
at places where that hasn't been the case. So it's really nice, and
that is nice.
Things have not gone wrong with continuous deployment yet, so we've been able to stick with it.
So one thing that I'm wondering about is it sounds like, even with Slax and some of the stuff that you're pulling together, that you're going to be running a polyglot system where part of the system runs in Elixir and part of the system of, eventually anyway, and part of the system runs in Ruby. So how do you get the two systems to talk to each other? Are you working out APIs for that, or are you still going to have some form of rescue or something like that, or what are you looking at there?
Yeah, that's a great question. I think kind of where we've settled at right now is that if it were something that we had to push this out today, probably the way we would do it is that, the rescue job that would normally be running the Ruby code to talk to, the scanner would just call out to an Elixir service and sit there and wait until the Elixir service comes back.
Mm.
So, and some of that is just an artifact of the way things are built out, where, the code that runs, the code that does the integration to these services is really just like a bunch of rescue jobs. There's not a true, service to manage all the importing of data. And so we are planning on building out a more formal service to like manage these, what we call connector runs, to go out and pull in this data and be a little bit more aware of what's going on. Because right now everything's very much isolated, and you can have two things going simultaneously and they don't know about each other because they're just two rescue jobs running side by side. They can't communicate. So I think in the medium term we would probably build out more formal APIs where we can communicate back and forth.
I was going to mention, not here suggesting anything because I have no idea what your system actually looks like, but I was going to mention for people that are listening, there's a thing called BERT, which is binary Erlang terms. Mm-hmm. And you can, so I recently used, I have a Elixir app that shells out to Python to do some PDF text translation and send me back a data format. And previously I was sending just like a table of data, so I just sent CSV and there was no big deal, but I needed to return richer data. And so I was able to use BERT to encode the data. And one nicety is you encode like integers rather than like when we were shipping with CSV, it was a string and I had to know to parse this field. Anyway, so BERT, pretty much every language has some BERT implementation. There's one for Ruby, and there's also a thing called BERT-RPC specifically for doing remote procedure calls using the BERT encoding. Anyway, so it's really cool if you need to just do a quick communication between two systems, and one of those systems is Erlang, or even if it's not, it's actually a pretty good encoding. If you're not, I've used it for that before. So anyway, it's neat.
That looks really cool. I hadn't heard of this before. I think, I typically fall back to JSON everywhere, but this would be a lot better than JSON.
New spike.
Yeah, exactly.
Yeah, I think I remember seeing a talk on this at like RubyConf in like 2008 or something.
Tom Preston Warner did the Ruby BERT thing, so that made me really happy. The first time I was using BERT and I saw I was using his code, I was like, all right.
Well, anything else we want to jump on this?
Yeah, I should also, just back to Sax Parsing for a minute, I should also point out, when I started this project, I did a Google search and I didn't find any Elixir Sax Parsers. So I went and did Slax. And then it took long enough that by the time I was getting around to actually publishing it and, putting it up on Hex, I did another Google search. And there is now an Elixir Sax parser called Saxy, S-A-X-Y, that is pure Elixir, right? So it's not relying on the Erlang library. It's pure Elixir. And according to the blog post announcing it, it's a little bit faster than Erlsom, the language that Slax is built on top of. So if someone's interested in, I think Slax is probably a little bit slower even than Erlsom, because I do a lot of translating strings to car lists and car lists back to strings, because it's a little bit, I prefer typing double quotes basically. So if somebody's looking for Sax parsing and wants to get a little bit better performance, Saxy is out there and, worth taking a look at.
Nice.
Well, thanks for sharing that. So I noticed from some of our kind of previous, prior to the meeting, I noticed that you were considering how this might be actually something that you could use with GenStage for, doing some more parallel or concurrent kind of things. I'm just curious as to where you see something like that would be helpful or how you would approach that.
Yeah. So GenStage was really what I was using to do the parallelization of the full import process. Right. So the API calls that we're making to take minutes of it at a time, using GenStage really makes it easy to say, all right, I'm going to kick off one API request, and when that comes back, I'll pass it off to the next stage and start processing that at the same time as I make the next API request, right? And so like you can, I was really looking for a reason to start playing around with GenStage, and so, it worked out well that I got to use it for the spike, and I think, GenStage to me is a really powerful feature of Elixir, and I'm really, I think it makes sense. It's not part of the standard library, but it's, it's nice that it's maintained by the same Elixir core team and it's not going anywhere. And it really, to me, it's been a great way to build out the system and to have the back pressure to say, I don't need to start parsing this document yet because there's nobody downstream who has the capability of handling the parsed document, right? And like all that stuff is handled behind the scenes by GenStage. I don't have to worry about it. I just, make sure that I have producers and consumers, and GenStage hooks them up and does all the plumbing for me. And so that was really nice. When I was designing, when I was doing Slax, I was debating whether or not there should be any thought of concurrency put into the library, and where I kind of landed was, it doesn't make sense. To me, it didn't make sense to build concurrency into that library, and that if you wanted to handle things asynchronously, you can just have your callback handler kick off the asynchronous part and like hand it off to a process, like fork a new process or hand it off to a gen server or something like that. But to keep the library simple and easy to reason about, it's just, it's very single process and very synchronous, and we don't move ahead in the parsing until your handler comes back to Slax and Erlsom.
Cool. Anything else we should jump on before we do picks? Josh, do you have some picks for us?
Yeah, I'm going to go with an article that I just found interesting. It's just about Rails. It's called "Who Gives an F About Rails in 2019," and I just found it interesting. It's not a particularly admonition one way or another, if I recall correctly, or at least that's the takeaway I ended up with was anyway. But we have a project. We do tons of stuff in Elixir. We have a project coming up right now that we might do in Rails, just because in this particular case, we know the client wants to, we know they will want to have a relatively cheap maintenance burden and not have to hire someone really full-time to manage it. And we know that they have a better shot at that in the current market if it's a Rails app. And it doesn't have a whole lot of like real-time anything. So anyway, I just thought it was an interesting article. I thought I'd share it.
Yeah, like I said before, I love the thought of the trade-offs, right? And some of the people trade-offs are the most interesting ones. So, yeah.
Having said that, I have no interest in actually writing a Rails app, but I don't mind. I don't mind managing teammates who can do it just as fast as if they were building an Elixir app.
Yep. All right, Mark, what are your picks?
So recently, I host the Utah Elixir Meetup, and I presented. And one of our members there recorded it, and he posted it online. So I didn't have to do that work, yay. And I was just going to share a link to that. So what it was is I gave a talk about gen servers and really how we need to get a mental model shift. And it's really all about, it's not so much like how do I read the code, it's how do I understand what the concepts are that is actually going on behind the code so I can see the code and now know what's going on. And a lot of it's just, it's a mental model shift. It really is. It's, coming from an object-oriented perspective to something that's more pure functional, where you're dealing with gen servers that act a lot like objects. So it's just kind of understanding a lot of this stuff. So everyone seemed to really enjoy it. And so I was going to share that as a resource that you can find on YouTube.
Awesome. I'll jump in with some picks here. I'm trying to remember what I picked on Ruby Rogues. One thing that I will call out on that particular show, so we just recorded episode 400 of Ruby Rogues, And so that it was kind of more of a meta discussion about where we were at and stuff like that. And we kind of got pretty deep on like life and things like that. So I am going to shout out about that. I think there's some good advice in there for folks who are trying to figure out which direction their career needs to go in. And then I'm also going to pick a game called Villainous, and it's a game. It's a Disney game, but it's for adults. I don't think even my 13-year-old would really get some of the subtle, gameplay that goes on. But essentially, what it is you each play a different villain that's trying to circumvent their fate, right? Because the story goes that the villains get defeated in the end, and so you play different villains, and the villains have different goals. So Ursula has to get the crown and the trident, and defeat Triton and stuff like that. And so different villains have different outcomes that they're trying to reach, and you can also sabotage the other villains, because the way you win is by getting your win condition before anybody else does. And so they have a fate deck, and so you can play their heroes against them, or different things from the various Disney movies. Anyway, it's really, really fun. Even if you're not a big Disney fan, the gameplay elements are really interesting, and so we've really been enjoying that. So yeah, I'll pick those. Ben, do you have some picks for us?
Yeah, I got 4. I'll try to keep it concise.
Oh, you're good.
So my first pick is a book. It's called The Soul of a New Machine by Tracy Kidder. So a little bit backstory about me. When I was growing up, I was fortunate to have a computer in my room from a very young age, and I'm old enough where that was unusual but not unheard of. So I had like a 386 in my room running Windows 3.1, and I played around with it, but I never really considered computers as like a thing I could do. Like, both my parents are lawyers. I figured I was going to be a lawyer when I grew up. Seemed like a good job. And then I read this book, and it was, about the process of basically inventing a new computer. And it just opened my eyes to what the industry is like, and what the job is like, and what the work is like. And, it kind of is the first thing that set me on the path to where I am today. Right. So it's about this company called Data General in the late 70s, and they were building mini computers. Mini computers are this, kind of Cro-Magnon man missing link between mainframes and PCs. And it's like, your company's not big enough or can't afford a mainframe, and PCs are still toys back in that time. So like, go get a mini computer. Right. And so Data General was a startup that was building, they had a successful computer, and then DEC, who was kind of the 800-pound gorilla in the mini computer market, they'd come out with a 32-bit VAX, and that was just eating Data General's lunch, and they needed to compete with them. The book follows the team who actually lost the internal bake-off of Data General to build a 32-bit machine. And they're like, well, we'll just upgrade the existing machine to 32 bits, and it'll be an insurance policy in case something goes wrong. Right. And so the book follows all the work that goes into the process of bringing a machine, both hardware and software, into life. And it's a great book. It's fantastically written. I mean, it won a Pulitzer Prize, for crying out loud. Like, I reread it about a month ago, and it still holds up. It's great. And it's been a big book in my life, just because it kind of put me on the path to where I am today. Next 2 picks are 2 papers / articles that I think are really interesting. The first is called Reflections on Trusting Trust. And it's by Ken Thompson, who's one of the inventors of Unix and the C programming language. So he received the Turing Award, which is basically like the Nobel Prize for computing. And when you get to the Turing Award, you get to give a speech and then publish a paper that's kind of summarizes what your speech was about. And instead of talking about Unix or C, he spoke about trust in computing, and basically, how do you make sure that your code, that the compiler is not inserting a backdoor into your code when you compile it? He's like, well, you can read the source of the compiler, but then you got to trust that, when that compiler was compiled, like, it didn't turn the source of the compiler into some nefarious thing, and it goes kind of, it turtles all the way down. And he makes the argument a lot better than I can summarize it. And it's like 3 pages long. There's a bunch of code listings. It really takes, 10 or 15 minutes to read, and it's really fascinating. The next article is called The Rise of Worse is Better. This probably would be a blog post, but I think it predates that term. It's available online still, and it's really analyzing, what it is about Unix really that caused it to win, right? So there was this big research effort between MIT and Bell Labs and a couple other places to build this thing called Multics, which is a very ambitious operating system. And that project kind of drug on and never really achieved its potential. But in the interim, these two developers at Bell Labs, Ken Thompson and Dennis Ritchie, in their spare time wrote Unix because they wanted to famously play Space War on a PDP-11. And so the paper looks at, Unix didn't have all these high, lofty goals that Multics had, but it won. Why did it win? Because it shipped earlier, and, clients will put up with bugs if they can run your software first and trust that you're going to start fixing things. And it's modular and composable and all these kind of things that we value in today's software. And it's really a really interesting look at that kind of stuff. It's a good perspective on, what matters and what makes software win. So my last pick then would be a utility, open source utility for taking screenshots. So I run Linux, and one of the things that I've missed going to Linux from OS X is Skitch. But there's a free software tool called Flameshot that gives me all the functionality that I need from Skitch. It lets you draw a rectangle on the screen, take a screenshot, and then draw arrows and text and annotate that screenshot very easily. And it's really simple to use. I have it bound to a hotkey, and I use it all the time, and it's just great.
Nice. If people want to find you online, where do they go?
The easiest way to do it is probably on Twitter. I'm bschmeck, BSCHMECK. Anytime I do anything, I tweet about it there. I also have a blog, blog.s10r.com. My last name Schmeckpeper, and it's S 10 letters and then R. But anytime I blog, I also tweet about it. So if you just follow me on Twitter, you'll find out about anything I'm doing online.
Awesome. Well, thanks for coming, Ben.
Thanks for having me. This has been a blast.
Yeah, it's been really interesting to dive into this and just see, learn about Sax Parsers, and also talk about some of the issues with, maybe migrating or sharing space between different systems. All right, well, we'll wrap this one up, folks, and we will be back next week. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.